Hello, my name is Bill Bryant, and I guess I'm applying for the instructor position at the facility. So briefly, what I was asked to do is explain a little bit about centrifugal pumps. Now, with going into this, I understand that there's three different types of students, right? There's the first type that's like, okay, I got it. Explain something, okay, I got it, let's move on to the next subject. There's a second type. It's like, okay, I've got it, but if you can just hit on a couple key points in here, then I'm good with it. The third type of student is the type of individuals like, all right, that didn't make any sense to me. So I need you to explain it again. Which is good for me because now I can adjust myself and my way of instructing in order to help them understand this, because I want everybody to understand what they're doing here. Okay. So briefly with doing that, what I want to do is just basically go on over centrifugal pumps, the basic operations of them, what they actually do, how they design, a little bit of troubleshooting, and go with that. So what I have right here as far as demonstration purposes is I've got a couple of junk pumps here, and I've got one that I actually borrowed from a friend, and to show you a little bit about the design concept and what they actually do. So what a centrifugal pump actually does. A centrifugal pump, in definition, is used to transport fluids from one source to another by means of an engine or an electrical motor. Now, we got a couple different types right here, which I was, good to run across. You got a couple right here that are driven with an electrical motor. And then you got another one right here that's driven with an engine. Okay, so, and what it does, it throws fluid from the center toward the outside. That's where your centrifugal pump comes into effect. That's the definition of pretty much centrifugal. Move fluid away from the center toward the outside. With understanding this, okay, and I hope everybody gets it, there's two things that a centrifugal pump needs to have. Okay, it needs to have an impeller, and it needs to have a volute casing. Okay, this right here is the volute casing, which a lot of people in terminology difference, they call it the pump casing, or its technical term would be volute casing. And we'll talk a little bit briefly about different designs and stuff on it. Now, what happens with a centrifugal pump? Okay, a centrifugal, what it does, it draws in liquid from a source into the center. Okay, and then it disperses it to the outside. So it comes in through the center and then slings it, the liquid, toward the outside of the pump is what it does. And what that does, that creates kinetic energy. Okay, basically energy in which a body possesses by being in motion. All right. As we're saying, fluid goes through the center, it goes through the eye, it goes toward the outside. All right, now within the designs of these, okay, well, we'll talk briefly about, there's a few different designs, there's several out there on the market, but right now we're just dealing with a few right here. A few different designs. As you can see with the, we'll talk about the casings for just a moment. The volute casings, all right, the pump housing, as some people call it, different designs on it, but basically they're all the same. You got an inlet, you got a discharge. This right here shows the where the inlet comes in, and this is your discharge side. Same way on this one. Here's the inlet for this, and I've taken it off for now, but here's the discharge. It comes out. So now we're wanting to move liquid from point A to point B. So what happens now, we draw up the liquids, whether it be gas or whatever, and it goes through the inlet and out through the impeller. Now with designs on the impeller, okay, it's very important to understand, how the impellers are designed. Usually most of them are got a curvature on the inside of them, and I'll take this apart just in a moment to show you. But those designs are very important to the impeller. And what it does, it helps gain velocity for the liquid to be able to discharge. Okay? So now what I'll do is I'll show you a little bit of a different design on this casing. and impeller, so we can get into that. All right, the casing itself, volute casing. You see, this is a little bit different design than what these others are. This impeller here normally we just have a casing go right over the outside of it, you know, a cap or a cover. This one here would also, okay? So what we've got here, this one's actually a two-part. It actually comes apart. As you can see, it's also got curvature and veins to it, and for the discharge side. Actually goes right down in there like that. Now with the, as far as talking about a volute casing, what that goes into is, all right, think of the volute casing is like a snail shell. You know, it starts off smaller on the outside, but then it gets larger toward the outside. Now what that does, it creates velocity, it creates pressure, you know, and all that's factored into it. So with all that in mind, also keep in mind there's different types of vanes, impellers, okay, and the vanes on this. You can see this is more of an aggressive type vane. Some vanes just make a simple curvature like that. So it depends on what you're trying to move. There's a lot of factors involved with a design of a pump, a centrifugal pump. You know, and the energy on these things, these produce, you know, it's, there's three factors that are involved with the energy on this. One factor being the density of the fluid, how thick it is, whether it be like just a water or a sludge or something with a lot of solids in it. The other factor would be the speed of the driver, okay, and the speed which actually turns the impeller. The other one would be the diameter of the impeller. Now we have right here a couple that's different sizes, different designs. Now with the impellers themselves, there's three different designs on those, basically. There's the fully enclosed, which that's what these two right here are. If you notice, you can't see any vanes, nothing on it. Okay, all the impellers are inside. All the vanes are on the inside of these. Now with the semi-enclosed or semi-open, however you want to use it, it's pretty much the same thing as inside here. The only difference is it don't have an outer covering on this. It only has a back covering on the vanes. Now with fully open, that would be just the vanes itself. You wouldn't have a back cover or the front cover. Only the inlet and the vanes. That's it. Now depending on what you're trying to move, whether it be liquids or sludge or something that's got a lot of solids in it, that would dictate on what type of vanes you need too. Now these are designed more for just moving like water, a liquid. Okay, everything's clean, it's running through it, it's no problems. These right here, which is, actually this, I borrowed this from some of the friends, so this is his mud pump, is what it is. So that would, you know, to siphon the stuff out of the ditches, it's got a lot of mud, semi-solid, stuff like that, and that's what these semi-opens are for. You also have the completely open design, which dictates a lot of solids, stuff like that that you may be trying to move. Now, with going with all that, it just depends on what you're trying to move. Something with a lot of solids, because if you try to move a semi-solids or something with a lot of solid material in it with one of these types of impellers, then you're going to be stopping up, clogging up all the time. It's not going to be able to transfer that fluid out. So let's briefly go on over the vanes, okay, and the impellers. What we can also do is tell you briefly about what happens. Fluid goes in through the center, as we talked about, and comes toward the outside. The volute, casing, and the impeller's design on it is what you need to figure out for what type of liquid you're trying to move. Now within the volute casing, let me see if this one has one. It's pretty prominent that you can tell. Okay, within the volute casing, it's got what they call a cut water. And what that does, that actually, you know, like this right here, it's a cut water. And what that does, when the fluid comes in, it actually directs the fluid to go out through the discharge instead of just completely recirculating the fluid all the time. So you gotta have something to direct it toward the discharge. Some of them are actually built into the casings themselves. You know, a lot of the bigger industrial type pumps do. But this one right here is just a mud pump, simple mud pump, so it's nothing that hardcore designed. So understand with this, and I'm trying to boil all this down a little bit here too. Understand there's several things that go into it. There's like your energy factors when you're trying to design this. All right. Number one is your density. Number two would be your speed, or RPM. Number three will be the size of the impeller. Okay, so those are three things that really need to factor in on the energy portion of moving fluids. All right, understand that there's three types of impeller designs. Okay, that would be your closed, semi-closed, and open. And those are all for moving different types of fluids is what you need to do. There's so many things that can be factored into all this. I can get a lot more extensive over stuff. There's so many principles involved in all this, but one of the things I do want to briefly touch on right here is troubleshooting with these cats. It's understanding what's going on. There's so many ways you can do it. Usually the first thing with troubleshooting is sound. I mean, most people be around pumps and stuff, and as time goes on with somebody new coming into it, they will know how a pump sounds when it's running. So they know if it's making a high-pitched noise, if there's something going on that don't sound normal. So that's the first indicator right there, that something's going on with the pump. The other thing that can go on is usually the second go-to is with pressure. Okay, they notice a pressure difference. And that can be done by making a trending chart, you know, and tracking all this. Tracking and trending, very important. But understand with trending, you can understand the pressures that are going on and watch over time. You know, as pressure drops from what normally is, then, okay, there's probably something wrong. It can either be with the driver or the pump itself. There's where you can also go into like a vibration analysis. There's tools out there for this that will monitor the vibration, you know, and usually set up through a PM or something. Every so often you go out and monitor this. But you take the vibrations, and that can dictate over whether it could be the pump problems, a driver, or bearings. Now these are simple ones right here, pretty much direct drives. There's big industrial type, you know, centrifugal pumps out there that's got, you know, this shaft and stuff. They usually have a couple of bearings on the outside of it. There's never a bearing on the inside, because that's where you got to bring in all your liquid to move. So it's usually a bearing or two on the outside that's going. Now with your monitoring of this vibration analysis, that's where you can help narrow it down and determine where there can be something with the pump itself or something with the bearings or even the driver for it. The other thing you need to understand about pumps, usually what goes wrong with centrifugal pumps is what they call cavitation. There's a few things that cause this. Cavitation, usually what happens going on with cavitation is when it don't get enough liquid volume coming into it, they just try to put out. So that could be many things. It could be a stop screen, a partially stopped screen. It could be the change of liquid. You can have good clean liquid. Now you're getting into like a semi-solids that you're trying to move. So all that factors into it. Now with cavitation, what happens is there's small bubbles that form inside this chamber. Okay. Now what happens with that is those are superheated, those bubbles are, and they explode. Now, when that happens, then you're destroying the impeller itself or even the casing. I've actually seen pumps that have exploded because of cavitation. Usually when you take these apart, start looking at them, you'll see I've seen chunks missing out of the vanes, chunks missing out of the back plates, out of the front plates, where they've just exploded is what they've done. And that's due to cavitation. Generally speaking, that's the biggest downfall of the pumps. Other things you look across is, leaking the pumps, pumps leaking. Generally speaking, a lot of the pumps have a rope seal to them, impregnated rope seal, that fits around the shaft itself tightly. And of course, with friction, there's heat involved and it swells up and it seals the pump off, is what it does. Over time, that eventually wears out, and you may have to replace the seals on it. So it's no big deal, it really ain't. Now with all this given right here, this is just a brief introduction to centrifugal pumps. They're very simple in design. How they operate is very simple. There's a lot more factors that can go into it as far as design, concepts, engineering of it, what you need to know to move product A, this product from location A over to location B. There's so many formulas involved in it. And one of the key things on that, with the formulas involved, is these pumps right here you can't see so well, but usually the manufacturer puts out data tags on the pumps to tell you how much you move, at how many RPM, the designs, and all this. So like I say, there's a lot of formulas you can use, and once you get used to them, it's no big deal, and it helps troubleshoot, it helps in design concept, and it helps with everything completely involved with the pump, the drivers, and the liquid. But like I say again, this is a brief rundown of it. I hope that y'all have got the gist of what I was trying to get across, and I do appreciate each and one of y'all's time for acquiring me for this. Thank you very much.